Hello everyone, I am Indrajyoti Gaine and presently I am a PMRF fellow and I am a PhD student at Department of Mathematics and Statistics IIT Kanpur. Before that I was a CSR fellow and I have cleared CSR NET with 108 rank. Okay, so from the last class we are discussing about the permutation and combination, and in the last lecture we have discussed about the definition of permutation, which is telling that a permutation is an arrangement in a definite order of a number of objects taken some or all at a time. That is, we choose few elements from the collection of all elements, and we will find the way to rearrange them. How many ways we can rearrange all those elements? So after that, we have mentioned that the number of permutation of n different objects taken r at a time was of this formula. So today we will see this how we obtain this formula. Okay. So let us study the theorem. So what is the statement? The number of permutation of n different order taken r at a time where r is greater than 0, less than equals to n. Here, note that the r we are taking here greater than 0. For the case r equal to 0, we will talk later. So it is a case for r greater than 0. That is, we will choose any positive natural number. Now you can say the positive integer. We will consider only positive integer here. At the time, and the objects do not repeat. Do not repeat is n into n minus 1 into n minus 2, so on to n minus r plus 1. Okay, so this is the formula. So how we obtain this formula? So let us see the formulation or how we obtain this result. Okay. So for that, let us consider we have n elements. N elements, and here we will choose r elements at a time. So you can consider this as r many boxes. You can consider as an r many boxes. Okay, r boxes. Now we want to find all possible choice of way or all possible way to put this n elements, not put this n element, just choosing r element from this n element. And how many ways we can choose r element from this n element without repetition. Okay, so in that case, what we will do here? So for the first position, the first point, you note that do not repeat. So repetition is not allowed here. Okay. Now for the first position, how many choices we have? For this position, we have n many choices. Let us use some different color. So for the first position, we have n choices. For second position, how many choices we have? So we put one element. So here we will have only n minus 1 choices. For this, we have n minus 2 choices, and so on. I will get. And for the last position, we will have only 1 choices, because after no. For the last option, we have only n minus r plus 1 choices. Okay, because already we have chosen r minus 1 elements. So we are left with only n minus r plus one element. Okay. So if we multiply all those things, then we will get this formula. The multiplying, we get all possible ways. Because why we multiply? Now one can ask that why we multiply these choices. Because you can see for n many choices, we have n minus one choices for here. Now for these two case, we have total n into n minus one choices. For this many choices, we have again n two choices. So for this, we will have n into n minus one into n minus two choices. For this, we have the next step. That many choices. Okay. So for each of them, we have that many choices. That's why we multiply. And after multiplying, we get the result that the number of permutation is n into n minus 1 into n minus 2, so on up to n minus r plus 1, which one can write like this also: n minus r minus 1. Both are same because just we are eliminating r many elements and we are just doing this. Okay. Now, how can I write it by simplifying method? So for that, we have to get introduced with the factorial concept. So what is the factorial concept? So before going to the factorial notation, let us understand what is the factorial tells us. So factorial tells us the number of ways one can put r many elements into r position, or you can say how one can put n many elements in n position. Like in the first case, if you see here we were choosing r many elements from n choices. I have n many element and we are choosing only r element. Now if I replace this r by n, then what we will have? In that case, we have n boxes, right? We will have n boxes. Because we have n choices. We want to pick n many elements. So how many boxes we will have? N boxes. 1, 2, 3 up to n. You can say n vacancies. Okay. Now for this position, how many choices we have? N many choices. For this we have n minus 1 many choices. For this we have n minus 2 many choices. Thus, if we go forward, up at the end, we will end up with here we have only two choices and here we will have only one choices. Okay. Now, if I write this, I mean how many possible ways we have to put these n many elements in n vacancies, that will be of the form n into n minus 1 into n minus 2 up to 3 into 2 into 1. And this is what we denote by n factorial. Okay. So what is n factorial? N factorial is the so the notation, sorry. The notation n factorial represents the product of first n natural numbers. Okay. So this is the notational representation of n factorial. So what we understand by the notation n factorial, that is, I think this. It is this. This is what we understand by the notation n factorial. Okay. Now, what is the significance of this n factorial that we understand from here? From here, we understand what is the importance of this n factorial. Now, I will see that how I can use this n factorial to get this permutation, or how to write this permutations, or this formula for permutation in some simplified manner. Okay, so before that, let us see some example of factorial. So let's understand what is the 5 factorial. So let us take some example. So if I write 6 factorial, so what will be that? 6 into 5 into 4 into 3 into 2 into 1. Let's multiply this. What I will get? 6, 5, 30 into 30 into 12 into 2. Then 720. Okay. So 6 factorial is what? 720. What about 3 factorial? 3 factorial is 2 into 1. Okay. So what I will get? 6. 4 factorial means 4 into 3 into 2 into 1. That is 24. That is, whenever we write some factorial like 4 factorial, 5 factorial like this, then we are just writing that element and all the possible natural numbers less than that number, and we will take the product. That's all. That's how we find the n factorial. Now, the question is, what is 2 factorial and 1 factorial? 2 factorial is 2 and 1 factorial is 1, which you can clearly see from the expansion. You just 1 into 1. What is the least possible integer natural number than 1? There is no possible natural number, right? There are possible integer, that is 0, but there are no possible natural number less than 1, because 1 is the smallest natural number. So 1 factorial will be equals to 1. 2 factorial equals to 1. Now the question is, what if we get 0 factorial? That is, in some case, if we get some 0 factorial case, how to handle that? What is the value of 0 factorial? That is a valid question. So for that, let us understand the formation. So for the case of n factorial, we write it like this, right? N into n minus 1 into n minus 2 and so on up to 2 into 1. So we can write it like this, n into n minus 1 factorial, because whatever is inside this part, that is nothing but n minus 1 factorial. So we can write like this. Therefore, one can write this like, okay, let's see the color. We can write like this, that n minus 1 factorial, this is equal to n factorial by n, given that n not equal to 0. That n not equal to 0. So here you can clearly see that if you know about this 4 factorial and 3 factorial, so if I put n equal to 4, so let us check that it will come or not. So put n equals to 4, then what we will get? Then 4 minus 1 factorial, this is equals to 4 factorial divided by 4. So what I will getting here? This is equals to 3 factorial. This is equals to 3 factorial. This is 4 factorial by 4. So obviously you can write it like 4 into 3 into 2 into 1 divided by 4, which will again give the 3 into 2 into 1. Or one can write like this, that if you know the value of 4 factorial, then they can put the value of 4 factorial like 24 and divided by 4, which will again give the number 6. Okay, in either way we will get up to the same value. Now what about n equals to 2? Then what we will get? 1 factorial equals to 2 factorial by 2, which is again 1. So fine. Now put, okay, let's write it a different color. Put n equals to 1. Then what we will get? 1 minus 1 factorial. This is equals to 1 factorial by 1. This implies 0 factorial equals to 1 factorial by 1, which is equals to 1. So this is an important result what we need to use in future, and which you need to recall. You can say that because this is not in general true. This is not a clear cut reduction. You need to manipulate somehow this factorial notation to get up to this result. So you should recall this result. It will be good for you. Okay. So how we obtain 0 factorial equals to 1? So just by formation of this, we just manipulated this factorial notation, and from there we have found that 0 factorial equals to 1. Okay. See, okay. Now using this, one can now how can I use this factorial notation to know the number this, to know about this number? How can I use that? So let us denote the number of permutation by NPR. Okay. So let us denote the number of permutation by NPR. Okay. So what is NPR? NPR means I have n many objects and we are finding all possible permutations for r many objects taken at a time. Okay. So by the formation of discussion of this today's lecture, we know what is the n factorial will be. N factorial will be n into n minus 1 into n minus 2 and so on up to n minus r minus 1. Okay. Okay. Now I can write this like here, n into n minus 1 and up to it will be up to n minus r minus 1. Then n minus r, n minus r plus 1 and so on. And we will end up at the point 2, 1. Right? Okay. It will be little can understand properly why I am writing like this. So let us explain it more properly. It will be difficult to understand otherwise. So permutation is given by NPR. Okay. Now what is NPR? It is equals to n into n minus 1 into n minus 2, so on up to n minus r plus 1. Okay, this is the formulation which I can write again like n minus r minus 1, r minus 1 inside bracket, whatever I have discussed here also. Yeah, right. Also, we can write like this also. Okay, but fine, this is fine. Now I will multiply upper and lower part by this part. N minus 2, n minus 3 up to so on, n minus r plus 1. Multiply upper side by, change the color, blue one, n minus r, n minus r minus 1, so on, 3, 2, and 1. So if I multiply the above side with this term, so I need to adjust the lower term with the same term. So I will adjust the lower term. How? N minus r, n minus r minus 1. So let us write here, there is no space, so let us write more terms here. N minus r minus 2, so on, 3, 2, 1. Okay. Okay. So by this, you can understand what is this representation. This is nothing but the product of n many natural numbers. First n natural numbers, because you can see from here 1, 2, 3, 4, 5, and so on is going on, and in between these terms you can get confused for these terms, but these terms is nothing but consecutive natural numbers coming between 1 and n, because we have chosen r, this is less than equals to n, greater than 0, and for the time being you can assume that r is strictly less than n for the case this I am discussing here. So r is strictly less than n. So all these terms will be come inside the n of the in the range 1 to n. So there will be nothing changed. So you can write the upper part as n factorial, right? Because that is nothing but the first in many in product of first in many integer natural numbers. Okay, so I can write this is n factorial, and what is the lower part? Lower part is n minus r factorial. You can see that n minus r into n minus r minus 1, that is I am reducing by 1 and we are getting the product. So that is nothing but the first n minus r many product of first n minus r many integers. Sorry, natural numbers. Okay, so from here I obtain a formula of NPR like this formula in the form of factorial. In the form of factorial. NPR is a form of factorial. Okay, so how we will write this? So whenever we need to find how the possible permutations where are many elements chosen among the n elements, so that will be of the form what n factorial divided by n minus r factorial. Okay. Okay. Now let us find for the case. This is the case for this is the case for r less than n greater than 0. So this is a case for r less than n greater than 0. Now what if r equals to n? If r equals to n, then what we will do? We will do. We will choose n many elements at a time among n elements. So that is nothing but we are distributing n many distinct objects in n many vacancies, whatever we have discussed in this example here. Okay, so that is nothing but npn, because here we are choosing n many objects at a time among n elements. Okay, because here we have chosen r equals to n case. So the number of permutation for n different order taken r at a time. So r at a time is replaced with n at a time. So we are choosing n many elements among n many elements. That's why the concept of this will come. So from this discussion, we can understand that the result will be n factorial. Okay, but what if I use this formula? So let us understand this. So if I put r equals to n, then n pn, which is equals to n factorial divided by n minus n factorial. Okay, so this will give us n factorial divided by 0 factorial. Now we have discussed the 0 factorial equals to 1 here. So this will give us n factorial. Okay, so whatever we have discussed in this example, this answer is true for NPR. Using formula also we will obtain the same result. Okay. Okay. Now what if R equal to 0? So first understand the case when R equal to 0. That is, we are finding all possible permutations where we are choosing 0 element at a time. That is, we are not picking any element. So what is the possible cases? We have n many objects and we are not picking any of them. So clearly that is, there is only one possibility, that is we are not choosing any element, right? So it should be 1. So let us check this, that this formula is giving us 1 or not. So the formula will give us np0, which is telling us n factorial divided by n minus 0 factorial, which is nothing but n factorial divided by n factorial, which is equals to 1. Okay, so thus we get that if I choose 0 many elements at a time and we find all possible permutations from n elements, we will get only one possible choice. Okay, so these all things we have done here is permutations, in which cases that is we are finding all possible ways where repetition is not allowed. So note here permutation, we are about the cases where repetition is not allowed. Now, if I allow the repetition, then what will be the case? So, in that case, if I have n many objects, and we are choosing r elements among them, then what is the cases? We have r vacancies. We have to fill this vacancy by this n many objects where repetition is allowed. Okay. Then for this case, we have n choice. For this we have n choice. For this we have n choice, and for so on. For this we will have n choice. So in together we will have n to the power r choices. Okay. So let us understand this difference, that in one case where NPR is the result of all possible permutations, where repetition is not allowed. But in the case when repetition is allowed, the number of all possible combinations or all possible ways to rearrange them is n to the power r, which is much, much larger. Okay. So let us understand few example using this. Okay, so understand one. In the last class, we have discussed some example, right? Okay. So we have example. We have understood this example that find the number of four letter words with or without meaning. That is, meaning is not important, which can be formed out by the letters of the word rose, where repetition of the letter is not allowed. Okay, and we have discussed that the total number was 24. Now today, let us understand this using the formula. So repetition is not allowed, so we can use the formula for NPR formula. So what is the number of words here? So four number we have, and how many elements we want to choose at a time, that is also 4. So what we will give it? 4 factorial divided by 4 minus 4 factorial, which will give us 4 factorial, which is nothing but the same result here. Okay, by that it is true. So let us understand this one. Okay. Okay. So here is the example. Suppose you have four different color flags. Suppose you have four different color flags, and you need to generate different signals using exactly two different flags. How many? Then how many different signals can be generated? Here we have discussed in the last class that repetition is not allowed. So four different colors we have. So n equals to 4, and how many elements we can take at a time? So too many elements. The two element, exactly two element we will choose at a time. So the formula will be 4p2. That is 4 factorial divided by 4 minus 2 factorial, which will give us 4 factorial divided by 2 factorial, which will give us 4 into 3. And here also we can see the result is same, 4 into 3. See, using the factorial notation, we can easily compute how many possible ways we can have. But keep in mind that permutation is used on those cases where repetition is not allowed. Okay? Okay. So let us go to the some example of permutation. So using this formula, one can solve some few examples, like how can I write this thing? Okay. So example. So one can ask this kind of questions using this formula, that NP5, this is equals to 42 NP3. Okay. So from here you need to find what is the value of this unknown, that what is the value of this N. Okay. So for that, what you need to do, you need to write this properly. So for that, N factorial divided by N minus 5 factorial, which is equal to 42 n factorial divided by n minus 3 factorial. Okay. Now if I calculate this, so what I will get, n factorial will be cancelled from both sides. So I will get n minus 3 factorial. This is equal to 42 n minus 5 factorial. Now understand that n minus 5 factorial is smaller or bigger? Obviously smaller. So I can write it like this: n minus 3 factorial divided by n minus 5 factorial is equals to 42. This will give us n minus 3 into n minus 2, which will give us 42. Now if I solve this, what I will get? N square minus 5n plus 6 equals to 42. This will give us, no, I have done something wrong here. N minus 3 and n minus 4. Yeah, this one is correct. Okay. So n square minus 7n plus 12 equals 42, which will give us n square minus 7n minus 30 equal to 0. Okay. So this will give us n minus 10 n plus 3 equal to 0, which will again give us n equals to 10 or minus 3. Now we know that n should be some integer, and integer cannot be, sorry, n should be a natural number, and natural number is positive. So obviously minus 3 cannot be a case. So n equal to 3. So they can ask some this kind of problems using the permutation formula, and you can easily calculate what is the value of n by just using the formula and proper calculation. Okay. Now let us come to one interesting example. So let us discuss this thing. Good. Let us consider this word. Let us consider this word. So how many word is it have? So you can see here we have three letters, G, O, and D. Okay. But here you can see that O is repeated once. That is, O is appear twice. Okay. Now, if I find the possible ways or possible ways to write a four-letter word using these four words, you can see using these three words, where repetition is allowed, then I can find how many ways I can have. So here we have four letters. That is important. If it has only exactly three distinct letters, but here we have four letters. Distinct letter is three, but number of letter is four. So one can write O G O D or O G D O. This will also be considered by the manipulation of letters from here. But from here you can't come here. From only these three words, using these three words, you can't come here. So I hope you understand the fact that why I am considering this number of letters in this case as a 4. Here number of letters will be 4. Number of letter is 4, but number of distinct letters is 3. Distinct letters is 3, but number of letters is 4. Now the question is, how many words can I obtain using the letter of this word without repetition. Meaning of the word is not important. Meaning of the word is important. Okay. So how many ways I can write this? How many ways? How many words I can find using these four letters? So just use the permutation formula. So number of words is 4. That is n equals to 4. And what? How? I mean, how? And which is the how many words I want? I mean, in word, how many letters I want? So in the word, I want 4 letters. So here, r equals to also 4. I hope it is clear. Why r equals to 4? Because we want to make words which have 4 letters. And here also we have 4 letters. So n equals to 4 and r equals to 4. Because we want to find all possible way of writing a word without meaning can be allowed, where we are considering in many or these 4 many elements among 4 elements. So we are considering all elements at a time. That's why in this case n equals to r, n equals to 4 and r equals to 4. So how many cases we have? We have 4p4 many cases, or you can say this many words I can have, right? 4 factorial divided by 4 minus 4 factorial is again 4 factorial, that is equal to 24, right? Now if you take some time and write 24 many words, you can see that repetition is making some no significant difference. In case, that is, you can understand from here that suppose GOOD. Here we have two O. Now let us denote like this. One is red O and another is blue. So whenever we are allowing repetition, that is not allowing repetition, that is fine. So if I fill the box of 4 words, here you can see I can write like this. So good will be also one word. So G D. We have no choice for these 2 questions. Now one can write like this, and one can write like this. Okay. So from different color, you can see that we are not repeating the word or repeating the letter, because we have 2 distinct O. One is red O, another is blue O. So the repetition is not, I am not repeating the word. Even though we can see that repetition is, the word meaning are same, and if you write the O as white, you can see that there is no significant difference. But as we have learned through permutation, we are not repeating these 2 words. These 2 are distinct, right? By the point of view of permutation, because we have one red O, one blue O. So one case, red O first, blue O second. Another case, blue O first, red O second. So these 2 are distinct case in the point of view of permutation. But in general, this O is not distinct, right? Both the O are actually same. So whatever we get, both are exactly same. G O O D G O O D. Similarly, one can see this case. Nothing but these cases. So first this is okay, G D and G D G D. So we are fixing those elements which are not repeating. So one case is this, another case can be this, right? But in general, it is actually this. So for all possible choices of GD, the O position is considering twice. Okay, red O, blue O, blue O, red O, like this. So for all possible choice of these two elements, for all possible choices of G and D, we are getting 2 factorial extra cases. Yes or no? Yes. So overall, we are getting 2 factorial extra cases for each choice of distinct distinct choices. For each possible way of representation, we are getting 2 factorial extra cases. So we can write like different way for all possible representations. Not I will say choices. I don't know why. Let's write it properly again. All possible representation we are getting 2 factorial extra cases. This is not a true fact. Then why it is not wrapping? Okay, it's wrapped. So for all possible representation, we are getting 2 factorial extra cases. So what is the actual case? Actual number of into 2 factorial. This is equals to NPR, that is here. What is here? Which is here 4 factorial, right? So the how many permutations we have? Number of, this will be equals to 4 factorial by 2 factorial. 4 factorial divided by 2 factorial, which is equals to 4 into 3, which is again 12. Okay. So how you obtain an actual number permutation? So in this case, the number of 12. So in this case, we are considering these two elements are same. These two are same, which was not considered in the case of permutation. Or if you apply direct permutation, you cannot distinguish between these two cases. But whenever we find the actual permutation, we will consider these two cases as same, because O is O. that is cannot be distinct O. We have two O, but for two O, we can't make distinguishable difference. So in case of root, you can say root. So root is root. That is, if I spell ROOT, then which O is first, which O is second, that will not be a matter. Root is the same meaning, or if you write like a TOOR or TREE, this E is whenever the E is same, the repetition will not be, or the order will not be that much important. Okay, so this fact will be is considered here. So this is discussed as permutation when all objects are not distinct. Okay, so this is what we say permutation. Permutation when all the objects are not distinct. Okay, so thus we can find when the cases are not distinct. So here we have only two words which are getting repeated. Now let us see more words which can be repeated. So the question is same, but the word is now INS TIEUTE. Okay, so this is the new word, and what I need to do? I need to do again. How many words I can write with or without meaning using these words, and the length of the word, or the number of words, number of letters used in the word will be same as this word. Okay, so how many words it will have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of letters we have letters equals to 9. Number of distinct letters, কত? It is equals to 1. That is what will be the number of distinct letters? INSTUE. Right? So 1, 2, 3, 4, 5, 6. 6 are the number of distinct elements which are considered in this word, but total number is 9. So what is the actual number of permutation? Because here T is repeated 3 times and I is repeated 2 times, and others are not that. Others are appeared once. So what will be the actual number of permutation? Actual number of will be first 9P9 divided by what? So T is appeared 3 times. Okay, so here only one word we had, and that was appeared 2 times. So that's why we repeated this divided by 2 factorial. Here T is appeared 3 times. Perfect. So I will divide this by 3 factorial. Again, I is appeared 2 times. For that, we will divide this by 2 factorial. Divide this by 2 factorial. Now one can ask that why divided by 2 factorial and 3 factorial twice, I mean again. That I will discuss in the next class. But today, just understand that in this case, we will divide by this thing. And if the number, if in general, if one asks that, if one see that the number of repetitions of each word is P1, P2, P3. Like here are 5 many words which are repeated, and the repetition number is P1, P2, P3. In that case, the number will be like NPR divided by that number of repetitions of these words, those factorials. Okay. So what will be the statement? The statement will be here. It will be the answer. It will be discussed in the next class. Why it will I will divide by 3 factorial and 2 factorial. But the theorem I can state. This theorem is telling that the number of permutation of n object number of permutation of n objects where P1 objects are repeated are one kind, P1 objects are of one kind, P2 are of second kind, and so on. PK are of kth kind. Then what will be number? N factorial, which is nothing but NPN. Okay, so I am writing this by n factorial because it is nothing but the n factorial divided by 3 factorial, 2 factorial. So n factorial divided by P1 factorial, P2 factorial, and up to Pk factorial. Okay, so next day we will discuss about this example first, how it is coming, how it's coming, and understand the fact, and using the example of 2 apple and 3 banana and all these things, we can understand this example, because in the case of word also one can understand these things. But if I compare with some physical phenomena which you are aware of, then it will be very much significant and you can understand these things properly. So we will discuss this thing. And in the beginning of the first class, we have discussed one example about apple and all those things. Yeah, where it is here. Yeah, there's apple cases that can be understand from here. That's why we were discussing how many ways we have to put this apple. So that repetition is doesn't matter. So here also repetition is doesn't matter. The repetition was not considered because repetition is not allowed. But here the repetition is doesn't matter actually. The repetition after which O is first and which O is second, that will not matter. So this thing will be discussed in the next class. So we will stop at this point.